Okay, this lab walkthrough session is being recorded and will be posted later this afternoon on the recorded presentations page of my TCC Blackboard for this class. It's just past 9 o'clock. Out of respect for everybody's time, I'm going to go ahead and start this lab walkthrough today. So we're going to be doing this 11.6.2 lab on data link layer, switch security, switch port security. And before I do that, let me flip this there's an announcement here. The drop date for this class has been extended because of the bad weather. So I posted that announcement on the top of the announcements page. Okay, so now let me go to, let me see, can I minimize this and bring up the document for the file itself. So here is the configuration. Here's the logical configuration for this lab. And what I'm going to do is, what I like to do first is, regardless of the order that he gives me in the lab to tell you to go through and perform these steps, what I'm going to do is put just enough configuration on these two switches and router to where I can use show CDP neighbors and plug that my wiring is good between all of them. So I'm going to start with the this is connected to the router, and it looks like it's erased because it says it's asking us to go into the configuration mode. It was previously plugged into the switch. It says switch above it. I'm having to swing cables because I only have 2 serial ports at my computer that I can connect to 2 console ports on 2 Cisco devices. So I was attached to the switches to make sure they were erased. Now I swung that cable from S1, what's going to be S1, I swung that over to the router so we can make sure the router's erased properly. Okay, so it looks like a router. If you do show version, that's the default hostname of router, and it is a router. And this typical router has got the ports that we need to do for this particular class. Okay, so I'm going to go to the privileged exec mode, and then I'll go to global configuration mode, and then we'll give this guy a host name of R1. And the only other thing I got to do on the switch, all the ports are up by default, but on the router, I don't need to put an IP address on that G001 port. Actually, on my router, it's G00. When you do this in the physical lab, let's do a show IP interface for you. I'm sorry, show protocol makes it easy to read. So our Ethernet ports are 0/0 and 0/1. When you do this exercise in the real lab here, we have G00, G01. The printed lab assumes it's a Cisco 4321 type router, and it's G001 and G000. So whenever in instructions he says use G00/1, I will substitute G0/1. So I'll go to the configuration mode. Now, when you do this in Packet Tracer, just drag the 4321 router into your topology, and it'll match perfectly. Okay, so let's go to interface, gigabit Ethernet. If I try to type 0/0/1, he'll say, nah, that's not my memory scheme. So it's just 0/1. And I'm not going to apply an IP address. I'm just doing no shutdown. That's all I need to do, because Cisco Discovery Protocol is on by default at the data link layer, and all I got to do is bring that port up and up. It doesn't need, Cisco Discovery Protocol doesn't need any kind of IP address to work. It's down below at the data link layer, not the network layer. Now the switches, I won't have to do that because switch ports automatically come up and up when you plug something into them. Okay, now I'm going to go swing cable. Okay, I swung the console cable back to the switch 1, and let me bring the other Terra term here. Drag it up a little bit. Got to drag down somehow. Okay, so the top one is through my COM1 port. That's going to be our S1. The bottom one through my COM4 port on my desktop PC is going to be to switch number 2. So let's make sure this switch is erased and doesn't have any configuration on it. Remember, with switches, you have to test for 2 things. You have to see if there is any kind of startup configuration that's been previously on there. So I'll do show startup configuration, and there's nothing. The other thing we got to do is we can type show flash and make sure there's no file called vlan.dat, because if there's an existing VLAN configuration on there, it stores it in the vlan.dat database management file. You don't want that there. As a shortcut, instead of typing show flash, you can just type dir, like the DOS file directory command, and there's nothing there. So this switch looks like it's really erased. Okay, let's check the second switch. So I'll go to the privileged exec mode and do a show start, and there's There's nothing there, and then I'll do the dir, and looks like there's no VLAN .dat file present there. So we should be good to go to configure these switches. Okay, now, before I proceed with the lab, what I want to do, I'm going to go ahead and give them a host name because I want to show Cisco Discovery Protocol neighbors to show that the wiring is proper on this lab. So I'm at switch 2 now still. Okay, I'll go to the configuration mode, and I'll give them a host name of S2, and I'll go ahead and save that configuration. And I'll go to switch 1, go to the global configuration mode, and say host name S1. Let's save that configuration. Now, if we flip back to the Microsoft Word document, you can see that switch 1 is in the middle of the topology. Switch 1 goes up to the 12 o'clock position. If S1 was a clock, the 12 o'clock position is going up to R1. The 3 o'clock position is going over to S2. So let's check and see if the wiring I did was proper here, because I like to do this because if your wiring was improper, this will catch that before you go well into the lab, and then you got to stop and erase the configuration and reboot the devices and start all over again because you were configuring S2 and you thought it was S1 and all the configurations are incorrect. Okay, so I'm going to jump back to switch 1 as our man in the middle. So would you please show me your CDP neighbors? And look, switch 1, according to the wiring diagram on the logical diagram on the first of the page here, S1 fast Ethernet port 5, 0/5 should go up to the gigabit 0/1. Now, when you do it on a packet tracer, it'll be 0/0/1. And the connection between S1 and S2, port 1 of S1 goes to port 1 of S2. So the diagram shows us that S2, the local interface of S1 is connected to the remote interface F01 of switch 2. So our wiring is proper, good. So we can proceed with the lab now without hopefully making any terrible mistakes and getting too far in the lab. Okay, so at the bottom of page 2, it says I've configured the network, I have cabled the network, I have proven that the network is properly connected by showing Cisco Discovery Protocol. Now, on step 2 at the bottom of page 9, we're supposed to load the following configuration script on R1. So let me swing my cable back to R1. And we're supposed to load this configuration script. Now let me see now, is this the one where I did the corrected script? I might be able to copy and paste here. Let's go to the lab printouts. Oh, I didn't do it for this one, so I have to type it in by hand. Okay, that's fine. That won't hurt me any. Okay, so we should be back to R1, and there's no configuration on R1 except that we have simply put in the I'm taping the lab right now. It's okay. Let's do this, but I'm taping it anyway. You cool? You okay? The printer guy's here.
Yeah, fine, thanks.
Okay, so I'm at R1. I'm going to go to the configure mode. And I'm supposed to type in the following stuff here. I did the hostname R1. Okay, so let's do no IP domain lookup. And then IP Dhcp excluded addresses 192.168.10.1 space 192.168.10.9. Type that in good. So those addresses will be, we normally exclude a few addresses for servers and things like that from the DHCP server. And then for the other DHCP scope, IP DHCP excluded addresses of 192.168.10.201 to 192.168.10.202. Did I type that correctly from 201 to 202? Okay. Now let's create our DHCP pools. So IP DHCP pool students. And then we'll give the network number 192.168.10.1 192.10.0 and a standard slash 24. The default router will be our friendly neighborhood router, 192.168.10.1, because these guys are on the VLAN 10. And the domain name is going to be, I'll just call it the TCC-Cisco. Okay, now we're supposed to create a loopback port. So interface loopback 0. And this IP address is given as 10.10.1.1 and a slash 24. Okay, remember, reminder, loopback ports never need, they're born alive. They're born already, no shutdown in the active state. You can shut them down if you want to, but they're already alive there. So if I do a show protocols here, we can see the loopback port is up and up. 10.10.1.1 was its address. It's a slash 24. And I didn't have to tap the no shutdown on it. Okay, back to the configuration mode, interface gigabit, and he calls 001, where we're going to be a slash 0/1 on our router, 1941 series router, which uses a different numbering scheme. Okay, IP, Dhcp, relay, information trusted. So we don't have any rogue Dhcp servers from that idiot vice president of marketing come out and wipe out our particular information. Let's give them a real IP address, 92.168.10.1 and the slash 24. No shutdown. I think I already did the no shutdown earlier with show CDP. I wanted to make sure that shows Cisco Discovery Protocol neighbors was working okay. Okay, now we're going to do line console 0. A logging synchronous, which if there's any, if a line pops up on the screen, says ports coming up and up and up, and you're in the middle of typing a command, it restores that line for you, and it's not so headache inducing. And then exec timeout will make sure that you're never logged off, even if you take a break or something like that. Okay, now let's verify the running configuration with show IP interface brief. We've got a few more interface ports on this than he does on here, but it's showing us that loopback 0 is 10.10.1.1, and it's showing us a gigabit 001 in our case, 001 on the lab printout. It's 192.168.10.1, and those two ports are up and up. Okay. All right. Now I'm going to swing over to the switch. Swing my cable over to the switch. Okay, back to the switch. The only configuration we did was the host name for the switch. So step 3, near the bottom of page 3, I did that config. I did the host name. And he wants us to do it on S2. And I think I already did it on S2. All right. And now we're supposed to prevent DNS lookups with the no IP domain lookup command. So I'll go to the configuration mode. No IP domain lookup. Repeat it on B. Config T. No IP domain lookup. And then he says we're going to configure. I'm going to skip the descriptions just in the interest of time in the lab. The descriptions are not executed. They're just a convenience when you go. It's like comments in the summary language code or programming code. Okay, now we need to set the default gateway. We need to do that or they won't be able to communicate with their other devices. Okay, so on switch run, I'm just above the part 2 boldface type on page 4 now. We're going to set the default gateway for the management VLAN. So IP default gateway is supposed to be 192.168.10.1 and exactly the same. Hi, come on, we're taping. Come on and have a seat. I'm taping, and when I finish taping, I'll help you start to get going. IP default gateway 192.168.10.1. Now let's configure our VLANs. So part 2 in the middle of page 4, configure VLAN 10. We're going to add VLAN 10 to both of these. We made sure that they were erased before we started, so there's no existing VLANs. So just to confirm, I'll do a show VLAN. Only the default VLAN is present. No ports have been assigned and created any new VLANs yet. So on S1, we are instructed to create a VLAN number 10 and give it the name of management. And the same thing on switch 2. VLAN 10, name management. Now, if I repeat that command, show VLANs, we've created the VLAN. We haven't assigned any ports to it. We'll do that later. Now let's configure the switch virtual interface, which is the management address for VLAN 10 on switch S1. And these are going to have us go to the global configuration mode and say interface VLAN 10. And his IP address is given as 192.168.10.201 and a /24. And no shutdown. Have to do that. And on switch 2, we're going to do a similar deal. Go to the configuration mode. Interface VLAN 10. That's the VLAN 10 of the 2 ports that the PCA PCB are going to plug into. And his IP address is 192.168.10.202. Oops, I misspelled that. 10.202. Shut down. Now we're going to configure the native VLAN. Go back to S1. We're still on the global. Let's see if I can do it from here without dropping back to the pure global configuration mode. VLAN 333. He took it. Name. Notice the prompt changed to config-VLAN. Name native. Now, when I configure the trunking on the switches, of course, they'll complain like crazy because the VLAN native VLANs don't match. They're both the same. So VLAN 333. Second switch. Name native. Okay, I'm finished with page 4. I'm going to go to page 5. Now we're going to configure the VLAN 999. So VLAN 999, name parking lot. And then VLAN 999, name parking lot. Okay, now we're going to do some switch port security. So on both switches, we're going to configure trunking between port 1 and port 1, because if you remember from the front page of the lab here, port 1 connects switch S1 to S2. So normally switches, wire segments between switches are normally configured to be a trunking switch, a trunking connection, because you want them to be able to share VLAN somewhere there. Bring focus back to both of our tier terms. Okay, so I'm in the right below step on page 5, just down from the top, part 3, configure switch security. I'm going to configure these ports to be trunking ports. So switch port mode trunk, and we'll see a bunch of garbage on the screen because they don't agree with each other yet. So interface FA0/1, switch port mode trunk. Now they both be trunking. Let's verify. Show interface trunk. And he says that port 1 is trunking to that machine. Check on switch 2, show interface trunk. So port 1 of switch 1 is trunking to port 1 of switch 2 now. Now here's the step I really like at the top of page 6. Switch port no negotiate. I don't like anybody to be able to come in and hijack my switch port. Like if they're working the help desk, the switch port would normally be access port anyway. But if I haven't do switch port no negotiate, they can come in and hijack the switch port, turn it to a trunk, and now they have access to every network in the company. So we want to disable that. Drag this down slightly. Can I drag this up slightly? Oh, come on now, quit that. There we go, now we can see it better. Okay, so we instructed at the top of page 6 to go to the global configuration mode for switch 1, config T, and say interface fast Ethernet 0/1, and then say switch port none, no negotiation. So the DTP, the dynamic trunking protocol, is now disabled. You will not transmit or listen to any DTP nonsense from any other device. Do the same thing on switch 2. Global configuration mode, interface fast Ethernet 0/1, switch port no negotiate. Okay, let's go down to step 2 and configure our access ports, because we want to place them. Remember that when we did the show VLAN, we created VLAN 10 and 333 and 999, but we haven't assigned any ports to them yet. Well, we're just going to assign some ports to port 10 for our PCA, PCB to talk to each other into the default gateway. Okay, so on S1, I'm supposed to configure, go to the configuration mode, and let's say interface range fast Ethernet 0/5 through 6. 5 goes back to the router. 6 goes to PCA. Okay, so switch port mode access, and then switch port access VLAN 10. Now let's check and make sure it took. I'll do show VLANs, and it looks like VLAN 10 has got ports 5 and 6 assigned to it, and all the other remaining ports are still over in the other VLAN. Okay. Now on switch 2, it's port 18, which goes to PCB. So I'll go to configuration mode, interface fast Ethernet 0/18, port mode access, port access VLAN 10, wasn't it? Yeah, they're both 10. In the interest of time, I'm going to skip this disabling of the unused switch ports, but at the bottom third of page 6, it talks about step 3 of securing and disabling unused switch ports. You use the interface range command and you do a shutdown on them. So if someone stuck into the wiring closet and plugged into a port and you're hoping to get something, you wouldn't be able to use them. Okay, so I'm to page 7 now, and we're going to go. Let me do the show interface status command, because they didn't used to use this a lot. They did never mention this. It was a CCNP topic, but it's a great command. If I do a show interface status, I love this command because it's like a combination of show interface trunk and show VLAN. It shows you what VLAN each port is assigned to. It also shows you which one of the ports have been assigned to be a trunking port. I would normally have type show interface trunk to learn that first line, and I would normally have type show VLAN to learn the other stuff. But this shows you very quick and easily. It also shows you from other stuff like which ports have a wire in them, what speed they negotiated at, and things of that nature. Okay, so down to step 4, and we're supposed to type show port security. Oops. Show port security interface FA 0/6. That's our PCA. And does it match what's in the print? It does. It's okay. Last session, okay. This is working fine. Okay, now on the top of page 8, we're going to change some of these default settings. So if I turn on port security, default is only one MAC address. That's probably too small. For example, with our VMs in here, he'll see the actual physical address of the Windows 10 physical computer, and then he may see 2 additional MAC addresses from the VMs. So sometimes we have to increase that when we do labs. 3 or 4 is a reasonable number to send to an employee or a student workstation location, because they might, swap a workstation around or replace a NIC card or something of that nature. But not more than that, because remember from the lecture, what if they run that program that blasts 10,000 MAC addresses, fake MAC addresses, into the switch MAC address table to fill it up so that it turns into a hub and not a switch again, and you can hear all the traffic. You're not supposed to hear it. Okay, so in the middle of the gray portion, highlighted gray portion of page 8, I'm going to type those commands in. I'm at S1, so I go to global configuration mode and say interface fast Ethernet 0/6, Let's say switch port security, which turns it on, defaults. Now switch port security, maximum 3 addresses. Switch port, we had our 3 violation modes. Oops, I'm stuck on caps lock. Violation restrict, which is the one that's very confusing. In the slide, it says it shuts it down. That does not shut it down. It puts it in the air disabled mode. To reset, you have to type shutdown and no shutdown. Just like when you switch belows on the circuit breaker barely moves. You got to push it off and then back on to turn your circuit breaker back on. So I got to type shutdown and no shutdown, resets the circuit breaker for this violation for this, and I'll turn it back on again. You can also set a timer where it'll turn itself back on automatically. Okay, the next line I'm supposed to type is switch port security, aging time. That's it. And then aging type, inactivity. Now let's repeat that show command, show port security. So what happened? Status line popped up on the screen when I was typing the command, and it restored the screen for me. Logging synchronous does that for you when the online con 0. So it should be enable, secure up, restrict, 60 minutes, inactivity disabled, and look, it has captured the MAC address. My MAC address is not the MAC address of the lab report. All MAC addresses are supposed to be unique in the universe. That's my MAC address. Then we're supposed to type show port security address. And this shows us everything is memorized so far, just this one secure dynamic one. Now let's do a similar thing on port FA08 on S2. Let me go back and just go back into the gear global configuration mode. And then we're going to say interface FA0/18 and say switch port security. This is the one I like, sticky. Sticky memorizes the switches memorize MAC address tables anyway. In the MAC address table, they lose them after 5 minutes. But sticky memorizes your security configuration that you desire to stay, and it adds it to the NVRAM. The NVRAM is what stores the startup configuration. When the power is lost and removed, it's retained. If I didn't use sticky, I'll have to type them all in again and make them learn them again. So I'm going to say switch port security, MAC address, sticky, and how to memorize it. And then we're going to configure aging time of 60. Configure maximum of 2 addresses, and violation protect. Remember our choices were protect, restrict, shut down. It's not really shut down, it's really air disabled. It's kind of like shut down, though it blocks traffic. But we're supposed to use protect. Okay, so let's do the show command. Show port security. Interface, Ethernet 0/18. It should be close to the print. Looks like it's close to the print. And then the other command was show port security address. There we go. Now I haven't configured the PCs yet. He didn't tell us to configure the PCs yet, did he? I'm looking back here. Configure basic switch. Is this going to be the ones where they forgot to tell me to do the PC? Is he actually going to tell us to span back and forth between them? He didn't tell us to do that. I'll go ahead and do that now because I guess he forgot to tell us that. So let's flip over to VMware. And I'll jump to our shortcut. Properties, because I'm pretty sure I have an incorrect IP address on here. I was doing something else earlier. Okay, PCA is supposed to be, Oh, he's getting it from DHCP. Okay, I need to set obtain IP address automatically. And do the same thing on B. Because obtain IP address automatically is their code for get it from the DHCP server. We normally use this everywhere because statically configuring everything is an annoyance. Shouldn't have to rely upon it. Too error prone. Okay. Okay, back to our switches. Okay, now at the bottom of page 9, we're going to do DHCP snooping security, which is the feature that prevents someone from bringing a cheap Linksys router or something like that, plugging it into their desk, and it's now sitting fake, improper DHCP, acting like a DHCP server for the whole company network. And everyone's getting the wrong kind of address, and they'll lose their connectivity with the company. Okay, so I'm instructed to go to S2, go to the configuration mode, and say IP DHCP snooping, and then specify for VLAN 10. Oops, keep hitting the caps lock. Now let's configure that port to be a trusted port. A trusted port, normally a trunking port that goes between the switch your employed PC is connected to upstream to the server data center somewhere. We want to trust the data center DHCP. That's the authorized server. You can also go into Microsoft Active Directory and authorize only the DHCP servers to work. So you can do it with Microsoft Active Directory, and you can do it with Cisco networking to give you a double-edged sword here against people accidentally doing something or people deliberately trying to break into your system. So I'm supposed to go to interface, F01, interface fast Ethernet 0/1, which is that trunking port, and say IP DHCP snooping, trust this connection. This is going up to the R1 at the top of the diagram. That's our trusted corporate environment that's being the DHCP server for the whole company. And then I'm going to set the rate at which it will allow DHCP requests to be made, because one of the hacks or exploits to break into your network and slow it down is to send a bunch of fake DHCP requests and try to slow down the system. So I'm going to change this to configure terminal interface fast Ethernet 18, the one that goes to PCB, FA 0/18. IP DHCP snooping and limitation rate of, I spell something? IP DHCP snooping limit rate. Oh, I'm not at the Ethernet port. I'm in a typing mistake. Okay. Interface fast Ethernet 0/18. Okay, IP DHCP snooping limit rate 5. Okay, so let's do a show command and show IP DHCP snooping. Okay, good. It matches the print. Now, let's see if we can get IP addresses on PCB. So I'll go to PCB, bring up the DOS prompt, and we're supposed to type IP. Well, let's see. Do I got anything right now? First of all, before I do this, what do I got right now? I've got an address. So we're supposed to type ipconfig/release, which tells the client to release the IP workstation address. And then we're supposed to type ipconfig/renew and see if it gets an address back. So I got an address back. And then we're supposed to look back on switch 2. and do a show IP DHCP snooping binding. Here we go. We got a MAC address. Okay, that's a MAC address of port 18 wrapped around the screen here, but it's 18. Now, port fast. It was our technique that, remember spanning tree protocol, it takes about 50 seconds. If you make a loop, the link lights are going to stay orange for about 50 seconds until they figure out what's the best, fastest, non-looping topology. And that's going to turn all those ports green. And then the one port remaining that could make the loop will be placed in an orange status. It'll be blocking or alternated. Port fast is our method that employees have PCs that are boot up and faster than 50 seconds. And there's someone really important, like the vice president of finance or something like that. He don't want to put up with his laptop that he paid $3,000 for. He's got to wait 50 seconds to log into the system. So, and we did this back in the old days with the Novell network workstations for secretaries. The old Windows PCs would boot up in 10 seconds because they were just a floppy disk. So I'm going to configure the port for port fast so that it'll come up more quickly. You only do this for ports that are going to another end device. Or in this case, it's going to port 6, which is PCA, and port 5, which is uplink to the router. There's no loops up there possible. However, he keeps listening in the background. If he hears a bridge protocol data unit coming in on the wire that you said, go up quickly, port fast, they'll say, oh, you lied to me. You plugged me into another switch. I'm going back to the regular STP because I don't want any loops taking place. Okay, we're supposed to be at S1 for this. So I'll bring up S1. And we're going to go to the configuration mode and say interface range fast Ethernet 0/536. 5 goes up to the router, no loop up there. That's the end of the line. And 6 goes down to PC-8. Now, spanning tree port fast. He warned you. Oh, if you're doing this with a wire between 2 switches, you could create a loop here and bypass STP and get broadcast storms and duplicate frames and duplicate addresses coming from different ports to a MAC address table to confuse a switch. So he warned you when you do that. Now we're going to do this on S2 as well. Go to the configuration mode. Yes, port 18, we may make it port fast. So fast Ethernet. Oops. Interface, fast Ethernet, 0/18, spanning tree fast. The warning appears again. Okay, now we're going to turn on bridge protocol data unit guard, which means all those ports that have been configured to be access ports, keep listening for the bridge protocol data units on them. So this happens when somebody in the company goes into CubeLAN and takes a cheap $10 switch from the office supply store and plugs 2 cubes together, he makes a loop. And the authorized switches up here are bridge protocol data units from the authorized switch, and they say, oh, someone plugged an unauthorized switch into the company network. They signed a form agreeing not to do that, but they did it anyway. I have to have a talk with that guy. Because they can tell when you do that, when you violate the stuff. They can tell when you plug in the stuff that's not allowed. Okay, so I'm instructed to be at switch S1 and go to the configuration mode and then interface fast Ethernet 0/6 and do a spanning tree PDU guard enable. And also on port 18 of switch 2, because those are going to our client devices. Configuration mode, interface, fast Ethernet 0/18. Spanning tree, PDU guard, enable. Now we're going to do show command, make sure this is set up properly. So I'm in the sort of the top third of page 11 of the lab, and I'm going to type show spanning tree interface FA 0/6 details, please. Interpret. So BDP guard is enabled. Yes, next to last line. It's been enabled properly. Now, I should be able to ping between PCA and PCB. Final test. That's why we didn't configure PCA and PCB. They got their addresses from the DHCP service. So here's PCA. Here's PCB is 192.168.10.11. And so let's see what A ended up being. It's probably going to be 12. 10. Okay, so ping 192.168.10.11, my neighbor, it pings. Okay, so we successfully assigned DHCP addresses to the two workstations. We successfully created a trusted DHCP environment so that only trusted devices could come in and get authorized DHCP server to give that to them. Now, all the answers on this lab report are filled out. So what I have asked you to do is simply send me a screenshot of your show run for R1 for those of you guys who are doing it at home. If you're here in the lab, my Big Brother software, my spy software, I can see. You don't need to do that here. You just need to turn the lab report, put your name on it. Okay, hang loose. I'm going to stop the recording.